Okay, so in this one we're talking about the library holiday party program. And this is their year levels at school. And we're going to make first the frequency chart. It's frozen, so you can't see the answers.
Does it have to be spread apart, or can it be like next to each other?
Yeah. So, guys, today we're going to talk more about histograms. Histograms is when they're going to be next to each other. In this case, they're going to be separated because nobody is going to be in grade level 6.5, right? That's not a grade. So you might be in level 6 or you might be in level 7 or level 8, but there's no 6.5. So that means that this data set is discrete. It can only be these integer numbers. It is not continuous. Any questions on how to set this up?
So even if there's none with space, we just like to put it.
Yeah, I just made it. What some people did, I guess, on another key I saw was they only used half a box for the space in between, but then it gets like a little wonky. You know, so you do make space in between. It doesn't have to be a full space. I get that it's hard to see, guys, but this problem is very similar to the one that we did before. Guys, that problem is very similar to this one right here. So it's okay if you don't have the whole thing down. It'll be in the video as well. I do want to do the last problem because that one was a little bit different. Let's see. Oh, and you're missing a few words, right? Under group discrete data?
Yeah.
Okay. Here's where we actually, in that next section, that's where we talk about, histograms. Okay, so in C it says, what is the modal year level of the children? So you can tell the mode because it's the tallest part of the graph, right? So the grade level with the most students is what grade? 7. Yeah, you can see that one here. Describe the shape of the distribution. So, is it skewed to the left, meaning like pulled to the left? Is it skewed to the right, or is it symmetric? Look over here. So this part over here, whenever it's pulled that way, then that would be skewed to the right. Yeah, but definitely not symmetric, right? Outliers, for right now we don't have a mathematical definition of an outlier. We're just going with, there's no spaces between, like there's no grade that has nobody in it in between, so we're going to say that there's no outliers, okay? And we'll come up with a better definition of outliers, I think, in the third lesson. So I'm on the back. I'm just answering these questions because some people are still looking at this. What percentage of the children were in year 8 or below? So that would be adding up 8 plus 9 plus 6, dividing by 30. Right?
Below would it be? Oh yeah.
It says 8 or below, right?
Yeah.
Yeah.
Is it the most?
Yeah.
Relative frequency.
Yeah, actually, Avalon brought up a great point. You could also just add up the relative frequencies there. Perfect. All right, so let's turn the page and see how those look. So try your method, Avalon, because it should give you the same thing that we get for this other method. And then the percentage of children that are above year 9. So there were 2 in year 10 and 1 in year 11 out of the 30 children. And we started to talk about group discrete data. So when you have a lot of discrete data points, even if they're still going to be whole numbers, say like I asked you, if I gave everybody a handful of M&Ms and I asked you how many M&Ms you have, it wouldn't make sense for me to like make a column for 1 M&M and a column for 2 M&Ms and a column for 3 M&Ms. Even though these are discrete numbers, I might say like how many people have 1 to 5 M&Ms, how many people have 6 to 10 M&Ms. And so those would be class intervals. And then continuous data has to be grouped. When you have continuous data, there is no way to list every single possibility. So, here it is brighter. When we measure data that is continuous, we can't write down the exact values. We write an approximation that's only as accurate as the measuring device. Since no two data values will be exactly the same, it doesn't make sense to talk about the frequency of a particular value. So I'm not going to say how many people are 5.321 feet high, okay? I'm not going to do that. Instead, I'm going to give you a class interval, like how many people are between 5 feet and 5'3". How many people are between 5'3" and 5'6"? The class intervals have to be equal width. And when we talk about the frequency of each class interval, we can make a special type of graph called a frequency histogram, which is what we had here. Here's your frequency column graph. Here's your frequency histogram. To display the continuous data, similar to a column graph, but the columns are joined together. Instead of having a mode, we'll have a modal class. All right, so instead of saying that the mode was year 7, if this was something that was continuous, I would say the modal class is between 8 and 9. A sample of 20 juvenile lobsters. This is what math questions are all about. Was randomly selected from a tank containing several hundred. So you know they don't want to measure all those lobsters. The length of each lobster is recorded in centimeters alongside. Organize the data using a frequency table and hence graph the data. So what we're going to do is we're going to make our length intervals between the whole numbers. Yeah. So our first interval will be between 3 and 4. Notice that we include the first number and we don't include the second number. So that if a lobster were 4 centimeters exactly, it would be included in the second interval. Okay, so once you have your intervals down, I want you to take a moment and get the frequency down. I'm going to start labeling my graph while you guys are working on that. All right, I got 3, 6, 5, 4, 2. That's what I got. Did I make a mistake?
That's what I got.
Remember that 6.0, remember that those are going to be included in this one and not in this one. Right, 6.0 because it says greater, or it says 6 is less than or equal to L. Okay. You got that? Okay. So between 3 and 4, we want a frequency of 3. And remember that this is a histogram, so these bars are going to connect. Between 4 and 5, we want a frequency of 6. Between 5 and 6, we want a frequency of 5. And then 4. And then finally 2. So something like that. Is that what you guys got? Okay. The modal class and state what it means. We have not done enough of the interpretation part of IB applications and interpretations. So say what it means is a good interpretation question. So the modal class is which of these? 4 to 5. Okay. And raise your hand if you can explain what it means to say that that's the modal class in terms of lobsters. I see one hand. I'm waiting to see if I can see a few more. Explain what that means in terms of lobsters. All right, go ahead.
It's the most common occurrence of length, but it's not the most, most lobsters aren't that way.
Okay. So Sophia said it's the most common occurrence of length, but that doesn't mean that most lobsters are that length, because it's not that more than half the lobsters are that length, right? I wrote it a little bit differently, but it doesn't conflict with what she said, so hers is also good. I wrote more lobsters are between 4 and 5 centimeters than any other interval. I can also say any other single interval to try to get at the distinction Sophia was making. Okay, and the distribution of the data, was it negatively skewed or positively skewed? Anybody can answer. You can just say it. It's positively skewed, right. So skewed to the right means positively skewed, even though every number on this chart is a positive number, okay? Skewed to the right means positively skewed. Did we have any outliers? No. Okay. All done.